All right, boys and girls, we're looking at equation 4 now. So finally, equation 4, we're going to look at this one. It's kind of a what would be called a time-independent equation. In other words, you don't need time for this. And this is for a problem where they're not asking for how much time it took, and they don't even tell you. So it does go from this speed to this speed, and it does accelerate at this rate and travel this far. And this is the relationship equation. So today we're going to look for x. I'm just choosing one randomly, so I'm going to do x, since it seems like we seem to use that one first most of the time. And so if I want to know how far it's moved, I need to know what speed it started at, I need to know what speed it ended at, and I need to know the acceleration rate. So I need to come up with a problem. I had to make one up that gives all three of those and ask for the distance. So, sorry for the misspelling, I just realized that. Far did it travel? So how far did it travel? So let's get started. Oops. Here we go. Oh, something was going on there. All right, so let's get started here. A car is driving at 10 meters per second when it begins to accelerate. So it started at this speed, and it accelerates at 4 meters per second squared. It does this until it reaches 30 meters per second. How far did it travel during this time? So let's write this stuff down. Let's go with, oops, there we go. VO, the starting speed, which is 10 meters per second. And let's go, that's a little O there. And the final speed it reaches is 30 meters per second. And what else do we know? We know the acceleration rate is 4 meters per second squared. And they're asking for how far did it go. Now there was an equation where we just needed the starting and the final, and it kind of like adds them and divides it by 2 and finds the average, but you needed to know the time that it took to do that, and we don't have that. So we're going to have to use this equation. Go ahead and pause at this point right here, and if you want to pause it and kind of look, the only equation that has this particular four things in there, VO, VA, and delta x, is this one. Okay, so I don't want to waste your time in looking, but go ahead and pause it and stare at it and look at it, and you'll see that that is the case. Which means we're going to have to use this equation, v squared is equal to VO squared plus 2a delta x. Let's plug everything in we know. That's the next step, right? So final is 30 squared is equal to 10 squared plus 2 times a, which is 4. That's the acceleration rate, times delta x, and that's what we're going to solve for algebraically. So let's just do a little bit of math. 2 times 4 is 8, and we'll put that delta x there, and we'll put the plus sign here, and 10 squared is 100. Let's get rid of those exponents. And 30 squared is 900, I do believe. Looks good so far. Let's minus 100 to get rid of this. Try to get that stuff over here by itself. So let's move some stuff over, which means I need a minus 100 over here. That makes that 800 is equal to 8 delta x. Ooh, the math is going to be nice here. Divided by 8. Divide by 8, and that's going to get rid of that 8 over here. And that's finally going to get that delta x by itself. And then 100 meters. That's the answer. So delta x is equal to 100 meters. That's it, guys. But I want to do a quick proof. So stick with me. I just want to do a separate way of solving this. It's going to be more of a two-step problem, like kind of a think. It's nothing crazy, but watch this. What is this right here? Let's see. So we have this car, and it's at 10 meters per second, and it goes until it reaches 30 meters per second. How much did it increase? So how much did it increase? It increased 20 meters per second. And what's its acceleration rate? 4 meters per second squared, right? That means it increases its speed 4 meters per second every second. That's what that means right there. So how many seconds would that take to increase your speed 20 meters per second? So it was 10, and now it's 30. So it increased by 20. So almost common sense tells us that if I'm increasing 4 meters per second every second, that's going to take 5 seconds, right? Think about it. Just pause it and think about it. Take your time for a minute. If my acceleration rate is 4 meters per second every second, that's how fast I'm increasing my speed this much every second. If I want to increase my speed this much, that's going to take 5 seconds, okay? That's going to be my time. It doesn't ask me for that in the problem, but I'm just trying to find a two-step way to get here. What is your average speed, folks? If I start at 10 and I end up at 30, what do you think my average speed is? Somewhere in the middle, right? So right about 20 meters per second. That's just a coincidence that happens to be the increase as well. But look at halfway from 10 to 20 is halfway from 10 meters per second to 30. Right in the middle is 20. So was I going 10 the whole time? No. Was I going 30 the whole time? No. I was changing my speed the whole time. But on average, we would probably say that my speed was 20 meters per second. I was going 20 meters per second. If you go 20 meters every second for 5 seconds, you're going to go 100 meters. Done. Look at that. Same answer. But this is easier. It's all one step. Some people prefer this method. If you prefer this method, you can do that. If this is like your if this is common sense and it's easier to get the answer this way than to plug it in this thing with squares and junk in there, this is just a way to do it with one single equation and we just knock it out. This one requires you to kind of really truly understand. And I'll be honest with you, I'd prefer everybody to do this method. But if that method doesn't make sense, definitely just stick it into the equation. Just do the method that I've kind of taught you, which is you just kind of write down everything you know, then look at the equation sheet and go, which equation has all those things? So don't forget to write everything you know and the one thing you're looking for as well. And what equation has all those things? Look for it. And sometimes there could be more than one. Just a warning, there could be. And then if there is, it doesn't matter which one you use. So pick an equation that does have everything, write it down, plug it in, and do a little bit of algebra. It's not much, a couple minuses and multiplying a little bit, nothing crazy, and get an answer. And that's it, you're done. If this way is easier for you, great. Then you got a physics mind, man. That means you have a really true grasp of how physics works. And hopefully this made sense too with you. All right, so try some practice problems with this one, and I like to see if you can do them. And if you have any trouble, make sure you're texting or calling me. That information is on the Google Classroom. I should have those numbers and everything up there for you guys.